Our class norms are to be kind, be respectful, and be working. If you are working, then 1 and 2 just kind of happen naturally. Today's learning objective actually should say wind and water. You know that the earth consists of useful resources and its surface is constantly changing. We will observe and identify slow changes to the earth's surface caused by weathering from water, but like I said, we're also going to do wind since we didn't get to complete that yesterday. Your warm-up champs expectations. Please make sure that you remain at a level 0. If you need help, raise your hand and wait patiently. Go ahead, Kaden. Your activity is reading, thinking, and solving, typing, drawing, whatever it's asking you to do. Your movement is to stay in your spot. Your participation is to stay focused on your work so that we can all be successful. Again, for your warm-up for today, I do want to go back and make sure that you can complete Wednesday and Thursday. So, go ahead and get on to your Canvas. I'll give you a few minutes to open up the warm-up. Thank you, Luke and Leah, for working on the warm-up as I requested. Guys, if you are still staring at this meeting, you are not doing what I asked you to do. You need to go open up your Canvas. Thank you, Kamani. Thank you, Layla. You need to go on your Canvas. Thank you, Cruz. Open up your warm-up. Thank you, Brian. Thank you, Bipaswi. There you go. You guys are getting it. Look at that. Look at that. All right. So, again, we're going to complete Wednesday and Thursday. Wednesday and Thursday. I am going to give you Wednesday and Thursday. Yeah. So, I'm going to give you a little bit more time today to finish both of those. And then we will go over them. Jordan. I think we went over this yesterday where we did a thumbs up if it was refraction and thumbs down if it was reflection. But I wasn't sure if you guys could record it. So we were going to go over Wednesdays again where it says examples of light being reflected and light being refracted are listed below. Circle all the examples of light being refracted. So, thumbs up A, while standing next to a lake, your image appears on the lake. Is that refracted thumbs up? Reflected thumbs down? You are correct. It is reflected. It is reflected. I don't know if it'll let me. Let's see what this does. Oh, wait. Nope. I'm not supposed to circle that one. Just kidding. That's an X, isn't it? Meow. There we go. All right. B says a rainbow appears as light shines through a prism. Refracted, thumbs up. Reflected, thumbs down. Refracted, thumbs up. Reflected, thumbs down. Good job. It is refracted, thumbs up. C says a student places a pencil in a clear glass of water and looks through the side of the glass. The pencil appears to be bent or distorted. Thumbs up, refracted. Thumbs down, reflected. Thumbs up, refracted. Thumbs down, reflected. Refracted, reflected. A couple of you have it right. It is refracted. So we're going to circle that one. Pencil being distorted. The key word there is distorted. If it's distorted or changed, it is a refraction. A man wears a safety vest with a reflective strip on it for added nighttime visibility. Refracted, reflected. Refracted, thumbs up. Reflected, thumbs down. Good job. It is reflected. Think about that. Reflective strip kind of gives it away, doesn't it? Sometimes things can be that obvious. E, a microscope has an eyepiece lens that magnifies the image. Thumbs up, reflected. Thumbs down, refracted. Thumbs up, refracted. Thumbs down, reflected. It is thumbs up, refracted. So we're going to go ahead and circle E. The idea is that it's magnified. That means it changes the image. Yes? Guys, can we hang on with... Oh, y'all can't see what I'm doing. I can fix that. Hey, Chloe, mute. Please do not just unmute and talk. I know it's really hard not to do that, guys. Please do not just unmute. I am recording right now as well, so I'm really trying hard not to say your names. Let me change what I'm presenting. There we go. It's moved all my drawings. Wait. There you go. There we go. All right. Number 2 says, in your own words, explain the difference between reflection and refraction. Reflection and refraction. It doesn't let me type. Kaden.
Is what I put it on Wednesday. Refraction is an image being distorted, and reflection is light bouncing back to you.
You are correct. Refraction is limited being distorted. Reflection is light bouncing back to you. Did y'all get that? I'm not going to type it or write it because it won't let me. It is refraction is an image being distorted. Reflection is an image or light being bounced back to you. Guys, if you don't have a question right now, will you turn your raise hand thing off? You think y'all are forgetting to turn them off. Thank you. Scarlett.
I only did it Wednesday because I remember I'm doing it. I think maybe I did it for Wednesday.
What?
I remember you called me and I did clean one for...
Okay. You just hadn't turned it off yet. All right, so Thursday says, hang on, let me change this. Thursday says, which statement below best describes how light travels? A, light travels through an object in a straight line. B, light travels in a straight line until it hits an object. C, light travels in waves. D, light bends when it hits shiny objects. I got a better idea. Hold up. 1 for A, 2 for B, 3 for C, 4 for D. 1 for A, 2 for B, 3 for C, 4 for D. What do we think it is? Y'all are all over the place. I got an idea. I'm going to find out what it is. Hang on. Because I thought it was one thing, and now that I read my answers, I'm thinking that's kind of a tricky one. Hang on. That's what I thought. I was right. Guess what the answer is? It's 2. It's B. Light travels in a straight line until it hits an object. Think about that. It bounces, right? Which means that it's going somewhere, and if it bounces, it reflects. Or if it hits water, it refracts. You know, if it's got an object in there and a clear water. Number 2 says, describe 2 ways you have used light energy in the past week. Hang on a second. Oops, wrong way. Your week 15, day 3. Now, I know today is Thursday, but yesterday we did, let me see if I can move this to the side. Yesterday, we tried to do the lab, but y'all were having issues with it. So go into, they're locked already. Go into Science Week 15, Day 3, Wednesday. What is weathering? So that we can work on that one. Okay, do not unmute if you have issues. Do not unmute if you have issues. Here's what I want you to do. If you find that you try to draw in it and it just disappears, close it. Try to get back in it. Chloe. Well, okay, Chloe, sweet dear. It's the Wednesday one. What is the Wednesday one? Because we couldn't do it yesterday because y'all's Cami files weren't working. So we're going to do Wednesday first. Chloe, are you looking at the list?
Yeah.
Do you not see the Wednesday one?
I do.
Click on it.
Okay.
Fantastic. Now try to open the file. Scarlett. Girl, you talk so fast I have no idea what you're saying. Natalie. Oh, okay. Guys, watch y'all's hand raising because it's taken a lot of time for me to go so-and-so, student A, student B, student C, and then you're like, I don't have a question. Like, you're taking a lot of time we don't have, okay? All right, so thumbs up. Cammy's working? All right. Then I am going to open this up so that y'all can see what I'm doing. So I think yesterday we talked about, we went through the lab. I went ahead and did it with you guys just so we could say that we went through it. But I'm going to go ahead and go through it again, right? So yesterday, you have your Cami file open, yes? Y'all are going to be toggling back and forth, or you can do a split screen like mine. You're going to be toggling back and forth between looking at the lab and looking at your Cami file. Thumbs up? Okay, so the first question in your Cami file says, which is stronger, wind or rock? What did we say was stronger yesterday? Natalie.
A rock?
We said a rock was stronger yesterday? I don't think so. Sujab.
The wind is stronger.
The wind is stronger. Why is the wind stronger? Khadijah.
Wind is stronger because it can actually carry around the rocks, I guess.
It carries around sand and sediment. It doesn't really carry rocks. And we'll talk about the difference here in a minute. So the wind is stronger because I'm writing with my mouse. So my writing's not all that great. You guys are typing it into your Cami file? Yes? Yes? You're all typing it into your Cami file? Yes? I need head nods. Yes? Kaden.
Well, I don't think the wind is stronger.
Why not?
I think the rock is stronger because it would take thousands of years to erode it.
Sure. No doubt it does take time, but that does mean that the wind is still eroding the rock, right?
Right.
The rock is not eroding the wind. The wind's eroding the rock.
I know.
Okay, it does take time, but the wind is stronger because it wears it away. All right, so I know that's hard to read, right? But thumbs up. You all have it typed in your Cami file, yes? Because I'm gonna erase it so that I can move on. Yes? Thumbs down. All right, we gotta go faster, guys. Gotta go faster. All right, some of you are still typing, so what I'm going to do is I'm going to show you the salt represents the wind, right? The chalk is the rock. Haha, chalk and rock, got it? So I am going to swirl the sand around actually I'm going to swirl the rock in the sand, right? And so do you see how the end of this looks a little bit worn out, but not too much? I'm going to set a timer for 1 minute, and I'm going to swirl it around. Set a timer for 1 minute.
Okay, 1 minute and counting.
And I'm going to I'm vigorously swirling it. It's not an easy task. I'm doing it kind of with a little bit of pressure so that it is wearing away the rock, because that's kind of what happens, right? The wind kind of applies pressure to the sand and sediment against the rock.
I think rock or the chalk because I didn't see because I was still writing.
What?
Oh, it's chalk.
Well, the chalk represents the rock.
Yeah.
All right. So did it wear it down a little bit more? Look at that. It does, doesn't it? It wears it down a little bit more, doesn't it? All right. So I'm going to go to the next page. Oh, look at that. That doesn't disappear. Let's erase that. And now we need to draw a diagram. And here's what I'm actually going to do. I'm actually going to draw it on another sheet of paper because it is really hard to write with my mouse. So let me grab a sheet of paper so I can draw what it looks like. So where it says, now you will test your predictions, draw a diagram of the experiment and label the parts of the diagram, okay? So I'm going to draw a diagram of my experiment. It's not a fancy drawing. So you are drawing this in your Cami file, yes? Nod, yes. You are drawing this in your Cami file, yes? Because you're going to hit submit in a second, yes? All right. Here's my cup. It's got salt in it. So I'm going to say cup, salt equals wind. Are you with me? Didn't take me very long to draw that, didn't it? Not fancy. It's a sketch. It's a sketch. I'm going to draw my chalk in here. I'm going to label that. Chalk equals rock. I'm going to give you 2 minutes to draw that. Set a timer for 2 minutes.
Okay, 2 minutes and counting.
All right. So then, where it says write your procedure, describe what you did to test your hypothesis. You are going to type in that you stirred the chalk, which is also the rock, in the salt, which is also the wind, for 1 minute. Okay? So we stirred the chalk, which is the rock, in the salt, which is the wind, for 1 minute. I'll give you 2 minutes to type that up. Set a timer for 2 minutes.
Okay, 2 minutes and counting.
All right. The next thing you're going to write is the result. So record what the results are and describe the result of the experiment. So what happened to the wind? What happened to the salt? What did it do? Chloe?
It kind of developed in the rock, the chalk.
It changed to the color of the chalk. So the salt, or parentheses, wind, right, changed to the color of the chalk. I don't know what that is. Which is also the rock. What happened to the rock? What happened to the chalk? Kamani, you're right. The chalk got smaller, didn't it? The chalk, so the chalk, or the rock, was broken down. It got smaller. I am going to give you 2 minutes on that one, and then we're going to hit submit, submit. Set a 2-minute timer.
Okay, 2 minutes and counting.
Go ahead and click submit, submit. Click submit, submit, and then go open up the one that says Science Week 15, Day 4, Thursday. We are going to push through on that one as well. So we are going to move on to thumbs up. You all click submit, submit. Submit, submit. You all have the Thursday one open? Yes? Thursday is open? All right. So the Thursday one looks a lot the same, but here's the difference. The difference is I now have rock and water. All right? I now have rock and water. So somebody mentioned earlier, and the first thing I want to talk about is what sediment is. So inside of when the wind pushes against rock, the sand and sediment it carries is extremely fine. So to show you what sediment is, I have two pieces of rock, right? They're chalk, but you get the point, right? If I rub them together, do you see what happens below? I got little pieces of rock coming off. That is called sediment. So you have the rock that are in my hands, and you have the sediment that falls apart, right? So the sediment is the little bitty fine pieces of rock that break off. So what do we think? Is water or rock stronger? Water or rock? Water or what? You have water. Water is W, or rock, make a fist. Water, W, or rock, make a fist. Which one do you think is stronger? Water, W, rock, make a fist. So it looks like most of us think that water is stronger. So go ahead and write that in there. Go ahead and write. I'm gonna write it. Let me. Ooh-wees. We're going to go ahead and say that water is stronger. It wears away tiny pieces of rock, right? And that's kind of what makes the sand. All right, while y'all are doing that, I am going to set up the lab. So what I'm doing is I'm taking a jar, all right? I have a jar here. I'm going to put these two pieces of chalk in it with the water. See that? Put the lid back on. And now I am going to set a timer for 2 minutes, and I'm going to shake it for 2 minutes, okay? Set a timer for 2 minutes.
Okay, 2 minutes and counting.
I am shaking vigorously. I'm shaking for 2 minutes. Now this is going to wear me out. I'm going to tell you that right now. It is going to wear me out. What do you think is happening? Do we think that the chalk is staying the same? Thumbs up. Or is it wearing down? Thumbs down. I agree. I think it's breaking apart. And I'm really hoping that it's not like completely dissolving. That would just be terrible, wouldn't it? So, did you notice how my chalk has rough edges? It has rough edges. Do you think that it's still going to have rough edges by the time I'm done? Thumbs up, it'll still have rough edges. Thumbs down, it's going to be smoother. Thumbs up, it's still going to have rough edges. Thumbs down, it's smoother. You guys are right. I think it's going to be smoother. Rocks tend to get smooth. The rough edges tend to break off and make the sediment as it rolls around and the water hits it. This is going to be fun trying to get this out of here. I think I'm pretty good. I don't think my 2 minutes is up, but I'm not going to lie. My arms are tired. So let's see if we can get these rocks out. See what they look like, right? Holy moly. Y'all look at this. What happened to that? Can y'all see that? Look at that. Kind of pretty, isn't it? It's kind of pretty. So I'm going to go over here and I am going to draw a diagram of what I just did. So again, it's not a fancy diagram, right? It's not a fancy diagram. Just drawing a sketch where I am going to draw my jar. It's not a fancy jar. Okay, I'm going to draw my jar, put some water in it, put some rocks. Right? So you have a jar, water, chalk, which represents the rock. Right? The chalk that represents the rock. Kaden.
I need to catch up.
Okay, well, you're going to have to go fast. And you may have to watch the video because time's almost up. Okay? But we'll be okay. You have until the end of the day. Okay?
Okay.
It'll be fine. All right. So then it says, describe what you did to test your hypothesis. Well, we placed the chalk in water and shook it for 2 minutes. And what was the result? The water changed color and the chalk became smoother. Yes? Are y'all with me? All right. I'm going to leave that there. This is typically when I disconnect from you guys. I run to the restroom while I get class set up. What I am going to do is I am going to leave this here for a second so that you guys can get that done. Don't forget, you do have to get on with Miss Harani. I am still going to run to the restroom and I'm still going to set it for my class, but I am going to go on mute and you need to stay on mute. When you are done with this, you need to click submit, submit. Thumbs up. All right. Get it done right now.